Hi there and welcome to PhD at Living. Today is the final main episode of our journey on the atomic bomb, and we're going to talk about Little Boy and Fat Man's combat use. We have the uranium, we have the plutonium, and we know it'll work. Probably. Actually, that's the first part of this video. Are we really sure it would work? It's a bit ironic that in early 1945, the two bombs had exactly the opposite problems. There was plenty of plutonium for the Fat Man bomb, but the feasibility of the implosion design was still very much in question. While Little Boy's design was basically on complete lockdown, but we weren't sure if there would be enough enriched uranium in time to affect the war. For that reason, the gun bomb's first use would be in warfare. There was still a chance, however, that with the Fat Man implosion design, a test was possible. Even still, Oppenheimer and Groves disagreed about the possibility of a test, Oppenheimer in the affirmative and Groves in the negative. Spoiler alert, Oppenheimer won. While the facts of this story have been true all along the way, I've rearranged the timeline a bit to make more sense narratively. The overall thread of the Manhattan Project comes together better if everything happens linearly, while in reality a lot of things were happening simultaneously because of the extreme time crunch of, that whole World War thing. Planning of the implosion test, named Trinity by Oppenheimer, actually began in March 1944. It sounds cooler though if it was like the first week of June 1945 and Oppenheimer was like, "Hey bro, you want to test this thing?" Physicist Kenneth Bainbridge from Harvard was named director of the Trinity test. You want to see how convoluted and professionally incestuous this entire series has been? At one point, Bainbridge worked for Ernest Rutherford. As a site for the test of the most powerful weapon the world had ever seen, a remote area of the Alamogordo Bombing and Gunnery Range, about 250 miles south of Los Alamos, was chosen. Obviously, the site needed to be far away from stuff for safety and security, but the remoteness of Trinity was good for one other thing you probably wouldn't think about. The MPs guarding the Trinity site had the lowest venereal disease rate of the entire US Army in World War II, so that's nice. The Gadget would be a full-size replica of the Fat Man assembly. So you've got the neutron initiator, the solid Christie pit, the tamper, the boron shield, the pusher, the explosive lenses, and the case. Originally, the Gadget would be enclosed in a giant steel container. That way, if anything went horribly wrong, the scientists could recover the precious plutonium. Nicknamed Jumbo, the giant container was 25 foot long and had a 10-foot diameter. The walls were over a foot thick and made of steel. Shipped from Ohio, at the time Jumbo was the biggest item ever sent by rail. As the date for Trinity approached, the scientists became more confident in the implosion design, and Hanford was pumping out enough plutonium that it really wouldn't matter if everything went wrong anyway. For that reason, Jumbo, instead of being used in the experiment, was dangled from a steel tower 800 yards from zero, the point of detonation. It would be a $12 million witness to Trinity, not a participant. Kistiakowsky x-rayed his explosives before the Trinity test and discovered they had voids. We've already discussed how catastrophic voids are because they mess up the shape of the implosion wave and screw up the entire timing of the core compression. One night, with a dental drill, Kistiakowsky drilled holes in the explosives and filled them with what I'm guessing to be a molten batch of either Comp B or baritol. RDX and TNT are pretty darn tootin' stable explosives in their own right, but drilling into them is still a non-zero safety event and, by the way, had never been done before. This understandably took some stones on Kistiakowsky's part. For what it's worth, in an interview in 1982, Kistiakowsky said about the process, quote, "Besides, you don't worry about it. I mean, if 50 pounds of explosives goes in your lap, you have no worries," end quote. As a run-up to Trinity, and to test a lot of the scientific experiments for the full-scale test, 100 tons of TNT with a little bit of irradiated uranium slugs from Hanford for radioactivity were detonated on 7 May 1945. Turns out an extra 16,000 pounds of TNT was put on top, who can count, and 108 tons of TNT were detonated. Some of the measurements worked great, some not so great, and others failed miserably. Among the myriad observations were experiments designed to measure the motion of the Earth during the explosion due to ground shocks. These tests weren't for scientific purposes though, no, they were for legal purposes, in case people sued Los Alamos for damages after news of the Trinity test became public. Always thinking that, government. A second run-up test to Trinity was an inert, meaning no radioactive material, copy of the Trinity configuration. That was fired 3 days before Trinity with very poor results. Everybody blamed Kisti and his explosive lenses for not being able to simultaneously compress the sphere. Imagine the gravity of the work, the enormity of the project, and you're the guy that messed it all up. Said Kistiakowsky, everybody at headquarters became terribly upset and focused on my presumed guilt. Oppenheimer, General Groves, Vannevar Bush all had much to say about that incompetent wretch who forever after would be known to the world as the cause of the tragic failure of the Manhattan Project. Jim Conan, a close personal friend, had me on the carpet, it seemed, for hours, coldly quizzing me about the causes of the impending failure. Sometime later that day, Bacher and I were walking in the desert, and as I timidly questioned the results of the magnetic test, Bob accused me of challenging no less than Maxwell's equations themselves. At another point, Oppenheimer became so emotional that I offered him a month's salary against $10 that our implosion charge would work. Hans Bethe analyzed the data from the failed test all night Saturday and discovered that even a perfect test would have given the same result. So nobody could know that the test didn't work. Kistiakowsky's reputation was restored, and it only took 24 hours. On Friday the 13th of July, 1945, at 1300 hours, final assembly of Trinity began. If the date and time seem ominous, Kistiakowsky had chosen them on purpose to bring luck to the test. The explosives were all set up, and the plutonium pit was called for. Louis Slotin and Harry Daghlian, who both unfortunately lost their lives in separate criticality incidents with the same plutonium core, monitored radiation through the whole process. Robert Bacher, who was in charge of the plutonium, went to add the pit, and it didn't fit. Expletives and incredulity filled the tent where the bomb was. But Bacher put forth a fairly simple solution. It was July in the New Mexico desert, and plutonium, a metal after all, had just expanded in the heat. After a few tense minutes to cool, the 6-kilogram plutonium sphere, about the size of an orange, slid right in. Over the next 2 days, final checks and preparations were performed. And then, on the day of the test, 16 July 1945, after weeks of drought, in the desert known as Jornada del Muerto, Journey of the Dead Man because of its treachery, a downpour began. Normally rain wouldn't bother a big weapon, but this weapon was special. First, the group wanted to observe the blast uninterrupted by clouds and stuff. Second, the clouds could absorb the radioactive fallout and literally rain radiation down on nearby towns as the storm moved. For that reason, the test was delayed an hour and a half from its anticipated 4 a.m. detonation. With meager accommodations in the middle of hell nowhere, everybody was roughing it. Vannevar Bush, head of OSRD and Oppenheimer's boss's boss, had his tent cave in 2 hours before the test. With nowhere else to go, he went to get breakfast. Emilio Segri had a unusual experience. He was awoken by the sound of hundreds of frogs humping in a big puddle outside his tent at base camp. You just can't make this stuff up. Manhattan meteorologist Jack Hubbard had previously told Bainbridge that the 16th was not a good day for the test. However, President Truman was meeting Stalin and Churchill in Potsdam on that day and wanted the results of Trinity for that meeting. Also, pieces of the test would not be ready for Bainbridge before the 16th, so he couldn't push the test any earlier. And so it was that the test was scheduled for one of the worst possible predicted days of weather. Anywho, the bigwigs met at 2 a.m. the day of Trinity, and Hubbard said conditions would be favorable around 5:30. The test was still on, baby! Observers were given thick, dark welding glasses through which to view the explosion. Richard Feynman chose to look through the windshield of a truck, figuring the glass in the windshield would protect him enough from the UV radiation of the blast. Here's Edvard Teller, quote, "We were told to lie down on the sand, turn our faces away from the blast, and bury our heads in our arms. No one complied. We were all determined to look the beast in the eye," end quote. In an instance that in any other case would be completely absurd, Teller passed around suntan lotion in the pitch black of 5 a.m. Robert Serber, who watched from Campagna Hill, 20 miles from Trinity, quote, "I was looking directly at it with no eye protection of any kind. I saw first a yellow glow which grew almost instantly to an overwhelming white flash, so intense that I was completely blinded. It took him half a minute before he could even see again. People 500 miles away saw the flash. Groves immediately sent a prepared statement as cover saying that the explosives dump at Alamogordo had blown up. The steel tower on which the Gadget was suspended was vaporized. Steel's melting point is probably about 1400 C, and to boil it almost certainly requires 3000 degrees C plus. Also, the silica in the desert sand was melted into a radioactive glass. That's about 1700 degrees C. The new greenish glass was called Trinitite. On the morning of 16 July 1945, the world now had the atomic bomb. Let's talk about mushroom clouds real quick. The detonation of the bomb creates a pile of low-density gases. These gases rise upward, creating the stem of the mushroom. Eventually, those low-density gases reach a height at which there's an equilibrium of their densities. Then they begin to kind of swirl around, and that's what makes the cap of the shroom. Come on, it's a mushroom. The senior men at Los Alamos had a $1 entry pool on the output of Trinity. Teller had 45 kilotons, Beta 8, Oppi 0.3, and Kisti 1.4. Trinity was calculated at 20 to 22,000 tons TNT equivalents, meaning visiting Professor I. Rabi won the pool with his 10 kiloton bet, which also just so happened to be the last one remaining when he entered the pool. Enrico Fermi dropped scraps of paper as the shockwave passed him and estimated Trinity's output at 10,000 tons TNT equivalents. Think about that. The dude dropped pieces of paper like confetti at a parade and estimated the first atomic bomb ever detonated within a factor of 2 on the output. Legend. On 26 July, President Truman and Churchill issued the Potsdam Declaration, demanding the Japanese surrender unconditionally or face, quote, prompt and utter destruction, end quote. Japan declined, and President Truman ordered Little Boy, the easier-to-construct gun bomb, dropped at the first reasonable opportunity. On that same day, the USS Indianapolis, which was sunk only 4 days later and is the subject of Robert Shaw's excellent monologue in Jaws, delivered Little Boy and the U-235 to the island of Tinian on the Marianas. Tinian was an important strategic capture for the United States because it was close enough to mainland Japan to allow for B-29 bombing raids. Tinian was also the forward base of operations for Project Alberta and the 509th Composite Group, who were responsible for assembling and delivering the bomb, respectively. On August 1st, Robert Serber and some other physicists from Los Alamos arrived on Tinian and assembled Little Boy. It was 10 feet long, weighed 10,000 pounds, and had 140 pounds of uranium enriched to an average of about 84%. As a point of reference for the critical mass, Little Boy had a criticality of right around 3. One reason why so much uranium was used was as margin. Against the scientists' best efforts, and there were many best efforts, the number of neutrons actually produced by a fission was still somewhat squishy, so they wanted to make sure they had plenty of fuel to make sure the bomb would go. For operation, 4 bags of cordite powder, basically a double base powder of nitrocellulose and nitroglycerin, would deflagrate and send the open cylinder projectile of enriched uranium slamming onto the rod target of enriched uranium. That would create the nuclear chain reaction, and that's how the bomb would work. The problem with having 3 critical masses of uranium here is in the event of an accident, bad things can happen. If there's any way to jostle one of these pieces loose and somehow meet the other in the middle, you could create a fizzle or a pre-detonation, which, while not full yield, would still blow up a lot of stuff in the area. Heck, think about this. The plane is leaving land and hopefully dropping the bomb on land, but between there's a whole lot of ocean. What's the ocean made of? Salt water. What happens if I drop this bomb in a whole pile of salt water and I get a beautiful neutron moderating water source between my 2 really big critical mass chunks of uranium? I could theoretically get a fission chain reaction going right here. To make matters worse, some B-29s on Tinian had a bad habit of not getting airborne before the end of the runway. For that reason, Captain Deke Parsons, group leader of Project Alberta and basically in charge of the non-nuclear components of Little Boy, flew with Little Boy as weaponeer and mission commander. Parsons took out the cordite bag charges before the plane took off to prevent any of the most likely accidents. In the air en route to mainland Japan, Parsons inserted the cordite bags back into Little Boy and fully armed the bomb for operation. On 6 August, Colonel Paul Tibbets flew the Enola Gay to deliver Little Boy. Named after his mother, Enola Gay is now stationed at the Udvar Hazy extension of the Smithsonian Air and Space Museum outside Dulles Airport in Virginia. Because Tibbets was ordered to deliver Little Boy visually, 3 scout planes were sent ahead to check weather condition at the predetermined cities. They would report back, and Tibbets would choose which would get Little Boy. After hearing the weather reports, Tibbets declared, quote, "It's Hiroshima," end quote. At 8:15, Little Boy left Enola Gay, and 43 seconds later detonated with 16,000 tons of TNT equivalents. Scientists at Los Alamos had previously studied the effects of European bombings and decided the atomic bomb would have a few critical differences. Number one, pressure effects at small distances would be higher. Number two, pressure effects at large distances would be lower. And number three, because radiation was produced, heat effects would be increased. In addition, if the bomb was detonated at a height, radioactive fallout would be minimized as much as possible. At detonation, the bomb was a pinpoint of purplish red light. Not an instant later, the cloud was half a mile wide and 10,000 feet high. The rarefaction part of the shock wave condensed water vapor in the air into a characteristic Wilson cloud caused by a rapid pressure decrease and adiabatic cooling. Within 1,000 yards of the epicenter, every human was instantly killed and many were vaporized. Shadows of where life used to be were silhouetted on structures as the radiation bleached the concrete around them. Within seconds of the initial blast, everything in the city caught fire. From Dawn Over Zero, quote, "Veteran B-29 pilots who participated in the largest raids on Tokyo and other Japanese cities, as well as in the great raids in the final stages of the war in Europe, agreed that nothing even approaching the effects of the atomic bomb had ever been observed by any of them." After being clear of the initial blast, the Enola Gay circled back to inspect the damage. The mushroom cloud was purplish-gray because the radiation had ionized the oxygen and nitrogen in the air, and the top of the cloud was 3 miles above the plane's altitude. It took 28 hours for the dust cloud to dissipate enough for pictures to be taken. Robert Serber, on the ground in Hiroshima shortly after the attacks, noted people who had shadowed sunburns on their faces. The scientists at Trinity had sunscreen. The citizens of Hiroshima did not. This caused sunburns that were directional enough to implant perfect shadows of where the person had been oriented during the blast. In all this, 0.6 grams of mass were converted to energy. In a bomb that weighed 9,700 pounds and had 140 pounds of enriched uranium, less than 1 gram of material was responsible for the devastation of Hiroshima. In announcing the atomic bomb to the world, President Truman was clear in his post-Little Boy statement, quote, "We are now prepared to obliterate more rapidly and completely every productive enterprise the Japanese have. If they do not now accept our terms, they may expect a rain of ruin from the air, the like of which has never been seen on this earth." The reaction at Los Alamos was one of joy, elation, and pride at a job well done. Shortly thereafter, realizing the horror that they'd been an integral part in creating, the mood sombered. It's tough for me to accept what I would have done if I was at Los Alamos at the time. I'd like to think I'd come to my senses pretty quickly, but I'm pretty sure that's just ego talking. I think I'd be incredibly proud and extremely honored to have contributed to my country in the war effort in that way. I have a very dear friend who I consider a brother serving active duty in the military overseas right now. And if he was in the Pacific Theater at this time in World War II, personally I think I'd want as many atomic bombs dropped as necessary to bring him home safe. Japanese military command in Tokyo was informed that Hiroshima had been devastated by a single bomb. Top atomic scientist Yoshio Nishina was asked if Japan could have an atomic bomb in 6 months. 6 years wouldn't be enough, was the reply, and at any rate Japan didn't have any uranium, so the chemistry wouldn't work anyway. Japan did not surrender. Back on Tinian, Fat Man was being put together. The implosion materials had arrived at the end of July while Little Boy was finishing assembly. Scientist Bernard O'Keefe was doing final checks on Fat Man and attaching firing unit cables when he realized one cable was in backwards. Instead of laboriously taking apart part of the implosion sphere and possibly delaying delivery of the bomb by upwards of a week, O'Keefe made the solitary executive decision to unsolder the cable connections, switch places, and resolder them in the correct orientation. He broke a number of rules in this process, namely putting a hot soldering iron within inches of a nuclear weapon, but O'Keefe did the job and made sure Fat Man was ready for delivery on August 9. 3 days after the bombing of Hiroshima, on August 9, 1945, the B-29 boxcar, now stationed at the National Museum of the United States Air Force in Dayton, Ohio, flew Fat Man to Nagasaki, where the bomb detonated with an equivalent force of 22,000 tons of TNT. Though Fat Man was more powerful than Little Boy, the damage was less cataclysmic in Nagasaki because the city sits in a valley and because the bomb was dropped slightly off target. Don't let that statement fool you though, the damage was still staggering. A Tokyo firestorm in World War II killed 100,000 people, but the city had 1 million in it, so the death rate was only 10%. Both Hiroshima and Nagasaki experienced death rates of 54%, a combination of the direct impact of the bombs and complications from radioactive fallout. The British metric standardized casualty rate calculated Little Boy as being 6,500 times more effective than a conventional bomb. It's a grisly and macabre way to say it, but that's probably the best example on how destructive an atomic bomb is. It takes life more quickly and effectively than any other implement of war ever created. The Japanese War Council was split, half in favor of continuing the war and half in favor of surrendering. Emperor Hirohito himself, in an exceedingly brave and selfless decision, made the final, inarguable call to surrender to the Allies on 15 August. The atomic bomb had ended World War II. Let's get real. For 6 episodes, I've been aggrandizing something that killed more people faster than any other weapon in the history of the Earth. There's an obvious moral elephant in the room here, but I'm only going to touch on the ethics of the atomic bomb a little bit. This isn't a political channel, so I don't think it's couth to judge from the peanut gallery 75 years after the decisions were made. There are a number of layers here that are geopolitical, moral, ethical, and militaristic in nature, and my background in chemistry gives me no expertise whatsoever to talk about any of them. What I will tell you is if Robert Oppenheimer came to the Department of Chemistry at my university during the war and told me that I had a chance to work on a weapon that would save lives and end the war sooner, terrible as the effects of that weapon would be, I would ask when I could start. At some point, Fritz Haber, and I understand the baggage that comes with quoting Haber, said some variation of this. During peacetime, a scientist belongs to the world, but during war, he belongs to his country. There are no easy choices in war. It is a terrible, unquestionably bad thing that should always be avoided if possible. But the Nazis were killing millions of people because they were the wrong race or wrong religion or wrong color or wrong something else. And for what it's worth, the Japanese killed at least that many Chinese, Korean, and Pacific Islanders for the same reasons. Does that justify killing 100,000 citizens in Hiroshima with an atomic bomb? Listen, I've taken a lot of math classes, but I honestly don't know. It's my personal opinion that an atomic weapon needed to be demonstrated in a live scenario at least once. We have people today who think the moon landing was faked, so how hard could it be for the government to film some videos, fabricate some data, and call it a day? Even German atomic scientists like Otto Hahn and Werner Heisenberg, guys responsible for trying to make the atomic bomb, refused to believe that Little Boy was atomic in nature. However, the results of Hiroshima and Nagasaki to this day cannot be ignored, and it is a testament to the terrible power of an atomic weapon that none has been used since Nagasaki. Tell you what, don't take my word for it. Let's hear from some folks who lived it. Arthur Compton, head of the metallurgical lab during Manhattan and a devout Quaker to boot. Quote, "As long as I am convinced, as I am, that there are values worth more to me than my own life, I cannot in sincerity argue that it is wrong to run the risk of death or to inflict death if necessary in the defense of those values." End quote. John Coaster Mullen, the infamous truck driver who made 2-scale, accurate, full drawings of Little Boy and Fat Man through painstaking research and old-fashioned cussedness, tells stories of reunions of the 509th Composite Group, which was responsible for dropping the bombs. Japanese citizens would occasionally attend these reunions, and members of the 509th would think they'd be ridiculed by those people. As Coaster Mullen tells it, though, these people would recount stories such as, quote, "I was 13, I was 14, I was 15. I'd been taken out of school. I was working at a munitions factory or whatever. I'd been given a grenade or a satchel charge or a spear and shown what rock outcropping or tree or bush to hide behind. The first GI I saw during the invasion, I was to kill myself and that GI in service to the Emperor. Because you did what you did, you took our military away from us. You brought freedom and democracy." End quote. Paul Fussell, a second lieutenant in the Pacific Theater, talking about the invasion of Japan if the bombs hadn't been dropped. Quote, "When the bombs dropped and news began to circulate that it would not, after all, take place, that we would not be obliged to run up the beaches near Tokyo assault firing while being mortared and shelled, for all the fake manliness of our facades, we cried with relief and joy. We were going to live. We were going to grow up to adulthood after all." End quote. And that, my friends, brings to a close our discussion of the amazing, complicated, wonderful, sobering, novel, labyrinthine, legendary, world-changing chemistry of the atomic bomb. Thank you, truly thank you, for sticking with me. I can think of no more fitting end to this saga than President Harry Truman's words unveiling the atomic bomb to the world after Little Boy was dropped on Hiroshima. But the greatest marvel is not the size of the enterprise, its secrecy, nor its cost, but the achievement of scientific brains in putting together infinitely complex pieces of knowledge held by many men in different fields of science into a workable plan. And hardly less marvelous has been the capacity of industry to design and of labor to operate the machines and methods to do things never done before, so that the brainchild of many minds came forth in physical shape and performed as it was supposed to do. Both science and industry worked under the direction of the United States Army, which achieved a unique success in managing so diverse a problem in the advancement of knowledge in an amazingly short time. It is doubtful if such another combination could be got together in the world. What has been done is the greatest achievement of organized science in history. See you next time.